Okay, guys. Hey, this is a Google Hangout. Hopefully, you're able to watch this. Sorry for being a few minutes late here. I'm actually 1 minute late, but just trying to get things taken care of at home. What I can see, I've got the. Hang on, let me enable it here. I've got question and answer. Let me see if I can. So what I'm going to do, if you can see this, is I am going to do 4 questions that were emailed to me. They're all from the practice final. I have a whiteboard, so I'll show you the work on the whiteboard, how to do it. And then if you guys have any questions, please send them my way. We'll work through it. I made the final today. It's going to come in around 70 questions. A little bit of questions are from WebAssign. I'd say about 10 questions. The rest of the questions are similar to WebAssign, but not as difficult, maybe. And then there's maybe 15 to 20 conceptual questions. Some things to think about, to focus on from season 2. Make sure you understand the motion maps, the oil drop pictures. Make sure you also understand position time graphs and velocity time graphs. Those are going to be on the final exam. It's been a while since we've done those, so we can review that tonight. I am just give me a second to try to figure out. I cannot do that. So let's see. Okay, so the questions that that I'm going to do. Hang on. We're going to start. I'm going to try to screen share this. Let's see if this works. I think what might be best is if you do have a question, if you can send it via email to helday@nths.net. And then we'll go from there. So what I'm going to do is I'm going to screen share here in a second. This is a question that was sent to me earlier today by a student. So let me open this up here. Hang on. So if you're watching the Hangout and you want to participate, I've got my emails open. I'm not sure if you can send a question via chat, but if you can send a question via email, that would be great. All right, so I'm going to screen share with you here. And what you see here, this is the question. We'll start with number 17 on the practice test. And this question came from Aaron Peltz in the early bird. All right, so question 17. Let me open this up here so we can take a look at it. Give me 1 second here. I'm just logging into WebAssign. Yes, that is my Christmas tree, our Christmas tree in the back. We're trying to keep it alive for the next two weeks, or at least not alive. I guess it's dead, but to keep it from drying out and getting needles all over the place. All right, so this is season 1 practice final. Hey, sweetie. So again, if you're watching this and you want to send a question, I've got my emails open. So please send an email my way. If you have questions, you don't understand how I've done something, again, send that via email. And I've got that open, and I'm refreshing that every couple minutes, so I can kind of check that out. So we're looking at, first of all, we're going to look at let's see. Swimmer swims in water. Oh, okay. So I do have the right. Okay, so the first question that somebody has here is this question. So I'm going to screen share this. This is number this is number 16 on the practice final. So if this is one that that you had trouble with, hopefully you can see my screen here. It says a swimmer swims in still water at a speed of 6.16 meters per second. He intends to swim directly across the river, then has a downstream current of 3.09 meters per second. So again, these numbers are going to be different for you, but it says what must the swimmer's direction be? Okay, so what we've got is we've got two vectors, and we've got to set up a vector diagram for this. So I'll show you how to do this. All right, so we've got our river here, right? And we know the river current. No, this is okay. The river current is 6.06 meters per second, or whatever it happens to be. The swimmer in still water can cross the river at 3.1 meters per second, right? And so you've got these two vectors. You've got the water rushing down this way. You've got the swimmer that can swim across this way. And it asks, what direction is he going to swim in? So if we were to look at this from above, right, the swimmer is not going to go directly across the river. He's going to go in this direction, because as he swims across, or she swims across, the river current is going to push in that way as well. So all we have to do here really is combine these two vectors. So I'm going to take this vector, and remember, I'm going to add it tip to tail, or tip. I'm going to actually add it tip to the tail of this one, right? Which is right there. So I'm going to erase this, and I'm going to say, oh, if the swimmer makes it 3.1 meters per second across, normally, and the river is moving at 6.06 meters per second across, then I'm going to find the resultant of that, 3.1 meters per second, right? And so I want to find the resultant of that. And I want to know the angle. If you look at the question, let's see, let's go back to the question. The question says, what must the swimmer's direction be? And so we're going to find this direction. And so it says 30.1 degrees upstream from straight across. So this is the angle then. I'll show you here. This then is the angle that that we are trying to find right here. And so if we do SOHCAHTOA, we should be able to calculate using sine. So we've got the opposite side, and we want to find the angle. So what I can do is I can do inverse tangent here. I've got the opposite side and the adjacent side, so I'm going to do inverse tangent of 6.06 over 3.1, and I'm going to solve that, and that's going to give me, so I'm going to check this, make sure we got this right, 6.06 divided by 3.1, second tangent. And I do this, and I get an answer of around 30 degrees, which is what the right answer is. So that's how you do this first part, okay, of the question. Second part of the question says, what is the velocity relative to the bank? So what we've got here is we've got these two vectors here, and we're trying to find the resultant of that. So Swimmer swims in still water at a speed of 6.16 meters per second. Okay, so what we actually have here, if we look at this, let me go back and explain this. So the problem says a swimmer swims in still water at a speed of 6.16 meters per second. It says he intends to swim directly across a river that has a downstream current of 3.09 meters per second. So the river has a current of 3.09 meters per second. Okay, he's going to try to swim straight across, but he's going to end up going right at this direction. And we know how fast he swims, right, is 6.16 meters per second. So what's weird about this problem, what's different about this problem, is we actually have the hypotenuse, and we want to know this velocity. We want to know how fast is he moving, or what is his velocity relative to the bank. And so we're actually finding this side of the triangle. So if we think about it here, we've got two sides. So we can do the Pythagorean theorem and say, this is A. So A squared plus 3.09 squared equals 6.16 squared. And we're solving for A. We want to see how fast he is moving relative to the bank. Again, I'm doing number 16 on the practice final, which is on WebAssign, which was requested by Aaron Peltz and Early Bird. So if you're watching and you want to come back, this will all be available to watch at your leisure some other time. And I think you can fast forward through this. So if this problem isn't one that's helpful to you, then don't worry about it. You can come back later and watch and kind of fast forward to different problems. So I'm going to find this A squared. So I'm going to use 6.16 squared minus 6.16 squared. Yep, and when I do this, I find this to be 5.32, which is the answer. So that one's a little different than other ones that we're used to. Okay. The next question that was asked was again by Aaron Peltz and the Early Bird. So I'm going to zoom in to this. He wanted to know 17, 22, and 23. Okay, so let's take a look at 17 on the practice final. All right, so I'm going to share screens again here so you guys can see this. So this is number 17 on the practice final. So it's the escalator problem. So go ahead and take a second and read that, and then we're gonna do this problem together, and then all right. So okay, so here's the situation with this, right? We've got an escalator, so I'm just going to draw it like a ramp, basically. And I know this distance is 11 meters long, and this is number 17 on practice final. So practice final number 17, if you want to check it out on WebAssign and see and kind of follow along. I know in the numbers I have, the escalator is 11 meters long. It says if a person stands on an escalator, it takes them 50 seconds to reach the top. So if I make a little table here of my knowns, I know my delta x, we'll call that delta x for distance. Remember, this delta x, it could be delta y or it could be d. Those are all synonymous. And so when you're using these season 2 equations or whatever velocity Vividat equation you're using, the y direction works as well. So that's fine to use. So this delta x is 11 meters, and we know the time is 50 seconds. And so from this, I can find the velocity of this escalator, which is probably my first thing I want to do. So I'm just going to find the velocity of the escalator. V sub e is going to be 11 divided by 50. And so I find the escalator speed is 0.22 meters per second, right? So That's how fast the escalator is moving. Now it says, if I were to get on this escalator and I were to walk up the escalator with a speed of 0.6 meters per second relative to the escalator, okay? Then what that means is I'm moving at 0.6 plus 0.22 meters, which is the escalator speed. So my actual speed isn't 0.6, but it's 0.82, right? Do you see how I did that? So I now know my velocity, we'll do V sub m for my velocity, is 0.82 meters per second, and I've got to cover 11 meters. So going 0.82 meters per second, how long would it take me to cover 11 meters? Well, remember velocity is distance over time, and I want to find time. So I'm going to do time equals delta x over v. This is going to be 11 meters, and this is 0.82. And I do that, and I get 11 divided by 0.82, and I get a time of 13.4 meters per second, right? So that's how long it would take me to go up the escalator in this problem. Hopefully everybody can see kind of what I did there. Yeah, so again, up here I found, I knew my initial distance and the time it took me, so I could find the escalator's velocity. I then found I know my velocity is 0.66 meters per second. I added those together to get a total velocity of 0.82 meters per second. And then solving for time, I know my distance is 11 meters, and I know my velocity is 0.82. I found the time of 13.4 seconds for the time up the escalator. So that's part A. And then it says, if a person walks down the up escalator with the same relative speed as in part A, how long does it take to reach the bottom? Okay, so we think about that here. If we were to look at this, right? So they're going to walk. They are going to walk. So let's erase some of this, right? So now here's our escalator, right? And again, this is 11 meters long still. And they're going to walk down at 0.6 meters per second. But the escalator is moving up at 0.22 meters per second. So what's their relative speed? Well, this is it's season 3 concept, the end of season 3, the last episode talks about relative speed, right? If they're moving 0.6 down and the escalator is moving 0.2 up, the net result of these two vectors is a speed of 0.38, I think, right? Is it a net speed of 0.38 meters per second down the escalator, right? If I add this plus this, they subtract from each other, and I get an overall speed of 0.38 meters per second down the escalator. And now I apply the same math that I did before. I know velocity is distance over time, and I've got my velocity now is 0.38, and I've got my distance is 11, and I can solve for t. When I do that, I get a t of 28.9 seconds, right? So there is my time it takes to go down the escalator when it's going up. Okay, so this is number 17 from the practice final. Again, if you're just joining the Google Chat Hangout thing, I realize I don't think you can talk live. So what I've done is I've got my email open. Send me questions, and I will go over these. I'm going over 4 right now that were sent to me earlier in the day, and we just did number 11 on the practice final. This is number 17 on the practice final. And next we're going to do number 22 from the practice final. So please email me. I've got my emails open, and I'll be checking periodically the emails to see what questions you have as you go. And again, if you get stuck on anything, shoot me an email later, and I can hopefully have time to make you a video. So the next question on this was number, let's see, was number 22 on. Was number 22 on the practice test. So let's open this up. So I'm going to screen share here one more time. So let's screen share. Okay, we're looking at number 22 on the practice test. It's this guy. And so I will solve this here in a second. present this to everyone. Yes, I do want to present. So hopefully you can see the screen share. We've got, this is the problem, and I'll go through this here in a second so you can understand that, what's going on. So hopefully you've got a mental picture of that. Go ahead and you can open your practice final up. So this is practice final number 22 on the practice final, okay? So it says we've got a 3.3, the numbers I've got, it's a 3.3 kilogram block pushed along the ceiling at a constant velocity with a constant applied force of 85.85 newtons that acts with an angle of 60 degrees to the horizontal and accelerates to the right at 5.24 meters per second. So here's our ceiling. We've got a block here, and we're pushing it with a force right here, right? This is our force. And this force is 85.5 newtons, right? So this force is at an angle. And it says that the force is 60 degrees with the horizontal. So, right, so this is 60 degrees to the horizontal. So that's how you draw this out. They also tell us the mass of the block. So this is 3.3. She okay, hon? This is 3.3 kilograms. And they tell us the acceleration of this, right? So if you think about this, if I know the acceleration of the block, and in the problem I have, it's 5.24 meters per second, right? And I know the mass, I can find the net force on this block, right? So if I think about this, right, this is F equals ma, and that might be useful because what they're asking for is they're asking us to find the friction of this block. So if I draw a free body diagram, here's my block, right? I've got my force applied in the x direction, right? Because if we see this is an angle, so we know it's going to be broken up into an x and a y. We've got the force applied, so my push force, in the y direction, right? We've got force of gravity down, and we've also got a second force down, which is going to be the normal force of the ceiling pushing down on my block. And then there's another force. As the block slides this way, there's going to be a force of friction, okay? So when I have my free body diagram, I realize that in the y direction, this Fay must equal Fg and Fn, okay? And then in my x direction, this force must be bigger than this force if the block is going to slide. And if I do F equals ma, it will tell me how much bigger this force is than this force, okay? So we can do F equals ma now and see what the difference is in between the force of friction and Fax. But let's first break this vector up into x and y, right? So I'm going to draw my triangle here, and I'm going to find my y, and my x. And give me a second here to do that calculation. I'm finding the y and the x component of the upward push. So 60. So I've got the y is 74.0, and I've got the x is going to be cosine, so 60 cosine times 85.5. This is 42.75, right? So if I come over to my free body diagram, the x is 42.75. The upward y push is 74.1. Fg, if I do 3.34 times 9.8, that will give me Fg. So I'm going to do that 3.34 times 9.8, and I get the Fg force here. This force is 32.7. So then Fn, which is right here, is going to be 74.1 minus 32.7. So I get Fn is 41.4, we'll say. So this is 41.4, and this is Fn. And we'll need that here in a second because I want to find the coefficient of friction, okay? I don't know this force of friction, but I can find it using F equals ma. So if I go ahead and do F equals ma, I know the acceleration and I know the mass. So I'm going to take 3.34 times this 5.24, so 3.34 times 5.24, and it gives me a net force of 17.5. Well, that means 17.5 is the difference in the x forces. So I know that 17.5 must equal 42.75 minus FF, right? And now if I see that, I can solve for FF, right? And so I simply subtract, I'm going to subtract 17.5 from 42.5, and that will be, so 42.75 minus 17.5, and I get FF is equal to 25.25 newtons. But remember, force friction, I want to find the coefficient of friction. Now I have this force friction. I remember that friction, so 25.25 is equal to mu times force normal. Force normal is 41.4. So now to solve for mu, I simply divide 41.4 to this side. And if I do that, I get mu is equal to 25.25 divided by 41.4. And I get 0.61. So I get a mu equal to 0.61. And that's how you do number 22 on the practice final. Okay, so that's number 22 on the practice final. The next question that was emailed in was looks like what Aaron want to do. Number 23 on the practice final. Okay, so the next question down. So we'll screencast this again. Okay, so here we've got this, and let's do a screencast. There it is. We're sharing. Sharing is caring, and I'm screen sharing. So I am very caring. We are doing number 23. Sorry, 23. Michael Jordan's number here. We're doing this problem, which is similar to the last problem, but a little bit different. This is find the magnitude of the acceleration of the crate. Okay, so I'm gonna unscreen share this. Okay, and erase the whiteboard here. So let's erase this whiteboard, and we are doing. Okay, so we're doing practice final number 23. Okay, so if you read the question, it gives us a crate. So we've got this crate here, and it's being pulled across a level floor by a force of 320 newtons. So whatever your force is, right, and an angle of 28 degrees above the horizontal. Okay, so that angle is 28 degrees. And it tells us the coefficient of friction. So what we can put here in our knowns, we know mu is 0.25. And I also know that the crate is 1,040 newtons, right? So if I do my FBD for my crate, I've got 1040 down, right? That's the force of gravity. I've got this force here is going to be split up into, so we'll call that force applied in the X. So FAX, and it's going to have FAY. And there's also going to be another upward force, which is the normal force. So we'll say Fn. And then there'll be the force this way, which is force of friction, right? And so, again, just like in the last problem, we see in the y direction, those forces are going to be equal, right? The box isn't moving in the y direction. And in the x direction, there'll be a net force. The box will be accelerating. And so, first thing, let's find FAY and FAX. So I'm going to split this 320 at a 28-degree angle up. So we're going to find the x and the y. So I do 28 degrees sine times 320, and I get this is 150.2, and then 28 cosine times 320, and then this is 282.5. Okay, so if we go to our free body diagram, my FAX is 282 right there, 0.5. Let's put the 0.5 in. Right, and then my FAY is going to be 150.2. And since the downward force of gravity is 1040, then the normal force is going to be this force minus this force, right? So I'm going to subtract these two to get what's left over for the normal force. So do 1040 minus 150.2, and that gives me a normal force of 889.2. So now I want to find the acceleration, right? And so if I'm looking for acceleration and I've got forces, I'm looking at F equals ma. On the test, the final, they're asking for acceleration and you've got forces, it's F equals ma, always. Okay? I've got the normal force. I've got the coefficient of friction, right? So I can just take mu times normal force. Remember, friction is fun. So I say, oh, the force of friction is equal to mu times force normal. And so this is 0.25 times 889.2. And I get a force friction. So force friction ends up equaling 222.45 newtons. Okay, and now I want to find the acceleration of this. This force is 282, right? The friction force in the other direction is 222. 222.45. So now the net force there, I subtracted the net force. So I do that and then subtract. So I do 282.5. And I get a net force here of 60.05. And I need to find the mass of this block to do F equals ma to find the acceleration, which is what we're trying to find. So I do 1040 divided by 9.8 to get the mass of this, and I get a mass of 106.1. And I multiply that, and I'm multiplying that by acceleration. So if I do 60.05, I get an acceleration of 0.565 meters per second squared. And so that is how you do number 23 on the practice final. And so that was another question that was emailed to me. So if you're just joining or you're watching this late, email me any questions you have and I can make you a video. The Google Hangout was a chance to kind of ask these questions live. I realize now that you can't actually chat with me as much as I thought. I thought it might be a little bit different. And then let's see. Okay, so those were the questions that have been sent to me. So for the rest of the night and tomorrow, if you have questions, email them to me, and I'll try to get you a video out. I should be up tonight until about 9, and then tomorrow I'll be up late tomorrow. So again, the final's made. It's around 70 questions. Definitely study the motion maps, the oil drop pictures. Make sure you study the velocity time graphs, position time graphs from season 2. In general, there's about 10 to 15 WebAssign questions, so questions pulled directly from either the practice final or old quizzes. I'm not pulling anything from old tests. And then the rest are kind of conceptual or easier versions of kind of WebAssign questions. So that's the makeup of the final. You're allowed an 8.5 by 11 sheet of paper, both sides. So whatever you want on it, you can put on it. And then make sure your calculator's in degrees, not radians. And that's it. So again, if you have any questions, please email me. I see we have one viewer. I don't know who that is. But if you're watching and you're like, oh, I have a question, send the question out. I'm gonna end this the Google Hangout here. And at this point now, if you have questions, send them my way, and I will be able to hopefully make you a video before too long. So, anyways, that was fun. I hope it helped some of you, and enjoy. Good luck on your finals this week.